Okay, so this video we're going to be looking at inverses of matrices. Okay, which is our fourth video in the topic. So, a matrix A has an inverse denoted A to the power minus 1, so the inverse of A, if A times the A inverse gives you the identity matrix. Okay, so A times the A inverse, if you multiply there, you get identity matrix. That's the condition for what's known as the inverse of a matrix A. Okay, so we'll look at a quick example to show that you can get this. So example 1, we're going to show that A equals the matrix 2 by 2, 3, 2, 1, 1, and B equals the matrix 1, negative 2, negative 1, and 3. Okay, so we're going to multiply, so that A and B are inverses. Sorry, there's my question, are inverses. Okay, so in order to do that, we're going to multiply that together and hopefully get the identity matrix back out, and then if we do, then we know they are inverses. So let's have a little space here. So A times B, okay, so that's 3, 2, 1, 1, multiplied by 1 minus 2 minus 1, 3. Okay, so I'll multiply this together. Okay, we'll probably be able to do a lot of this now quicker. We've seen a lot of basic multiplications. Okay, so row into the first column, 3 times 1 is 3, plus 2 lots of minus 1, which is negative 2, 3 plus minus 2 is 1. Row into the second column, 3 times negative 2 is negative 6, plus 2 lots of 3, which is 6, negative 6 plus 6 is 0. So I've got 0 in that second entry in that first row. And then, similarly, second row into the column, so 1 times 1 is 1, plus 1 lot of negative 1, that gives me that down to 0. And 1 lot of negative 2 is negative 2, plus 1 lot of 3, that gives me back 1. Okay, as you see, we get the identity matrix back, therefore A and B are inverses. Okay, so if you get the identity matrix back out, we know that two matrices that we had are inverses of each other. Okay, so what we're going to do is we're going to actually work out a way in how you get the inverse of a matrix. Okay, so if I give you a matrix, how can we tell if it's got an inverse, and if it does, how can we find it? Okay, so the inverse, now it works in different scenarios. Okay, now you can only do this with square matrices. Okay, so the inverse of any 2 by 2 we'll start off with. Okay, so 2 by 2 matrix. Okay. And then we'll look at the 3 by 3 case, which does get a bit more involved, okay? But the inverse of any 2 by 2 matrix, okay? So, the inverse of matrix A, again we'll use our general case for A, B and AB, CD, okay? Well, is A to the minus 1, that's the inverse. And how we work it out is it's 1 over AD minus BC multiplied by, you multiply it into the matrix D minus B minus C minus A. Okay, so that's actually how you get the inverse of a matrix A, okay? Now what this actually is, you might notice that denominator there, that is actually the determinant of matrix A. Okay, so it's actually 1 over the determinant of A. We looked at the determinants in a previous video. Okay, then you multiply it and basically you swap D and A about and you change the signs of B and C. Okay, so that's the sort of formula that allows you to work out the determinant of any 2 by 2 matrix there. Okay, so that's what we're going to use. Okay, so look at an example to show you just how that works. But this comes down to, I'll just make a wee note here, where AD minus BC is the determinant of A. Okay, determinant of A. Okay, so that's where that comes from. That's why determinants get used as well. But this comes with a bit of criteria. So if the determinant of A is 0, because we sometimes can work out a determinant of a matrix and get the value 0, therefore A does not have an inverse. Okay, so A does not have an inverse, and we say it's a singular matrix. Okay, so if a matrix A doesn't have an inverse, I forgot to write here. If determinant A equals 0, I'll put that there, sorry. So if determinant A equals 0, therefore A does not have an inverse, therefore we call that a singular matrix. But if the determinant of A does not equal 0, okay, therefore it has an inverse, and what we say is that it is non-singular. Okay, so that's just some terminology you need to be aware of. Okay, so if something's singular, it means the determinant was 0, doesn't have an inverse because we can't work out using our formula because you'd have 1 over 0 here and it wouldn't work. Okay, something doesn't have, if the determinant is non-zero, therefore it does have an inverse, but we call that non-singular. Okay, so it's a bit phraser. So let's look at an example to see how you would do a question. Okay, so let's look at example 2. So example 2, given that A equals the matrix 4, 3, 2, 2. Okay. Find A inverse if it exists. Okay, if it exists. Okay, so solution is, well, first thing we need to do is check whether it has an inverse or not, and that comes down to the determinant. So we need to work out the determinant of A. Okay, so remember that is AD minus BC. Okay, so remember where those positions would be in your matrix. Okay, therefore here it would be 4 times 2 subtract, in this case, 2 times 3. Okay, therefore, if you do that correctly, you get the answer 2. But the main thing is it's non-zero, therefore A inverse exists. Okay, so you always check the determinant first. Okay, after that, well, let's now find the inverse. So A inverse was 1 over the determinant of A multiplied by, well, D and A switch, and we swap the signs of B and C. So that's 1 over 2, and then we swap the positions of where A and D would be, so that would be 2 and then 4 in the corners now, and then we change it to minus 3, minus 2. Okay, and if we put a half into that, then we get 1 minus 3 over 2, minus 1, and 2. And that would be A inverse there. That would be the inverse for the A matrix there. You okay with that? Cool. Okay. So a lot of the times in that advanced higher, you're going to be asked about 2 by 2s. Okay. But you can be asked about 3 by 3. It doesn't happen very often because it takes a longer time. I'm going to show you one example, okay? But that is the case that comes up a lot, okay? So we can do that. Let's have a wee go at, let's have a look at a 3x3 case, okay? So, the inverse of a 3x3 matrix. Now for this we're going to need our Gaussian elimination skills. Okay, you're going to see why once we set it up, but our row operations will be very important for us here. Okay, so if A is a 3x3 matrix, provided A inverse exists, okay, so you'd work out the determinant of a 3x3 matrix, which we've known how to do as well. Then, well, we've got the same scenario, okay. Then A times A inverse would equal the identity matrix. But also, if I've done A inverse times A as well, okay, I can multiply them the other way around and I'll still get the identity matrix there. Okay, so providing it exists, we find it, then we know if we times it by each, so I'll get there. Okay, same again, so if the determinant of A is 0, okay, then A inverse does not exist. Okay, so it still comes down to the determinant being non-zero for this to work. Okay, so to find the inverse of a 3x3 matrix, we use row operations similar to Gaussian elimination. Okay, so those skills that we've done for Gaussian elimination will be utilised again. Okay, because what we're trying to achieve here, okay, so we start with the augmented matrix as matrix that says. Start with the augmented matrix A with the identity matrix to the right of it, okay, and turn into I with A inverse on the right hand side. So what that's saying is we're going to start with our matrix A on the left hand side with the identity for a 3x3 next to it. We're going to apply row operations so that we're going to turn A into the identity matrix on the left hand side, and when we've completed that, what we're left with on the right hand side will be the A inverse. Okay, that's what that's sort of telling us there. Okay, the best way to show is for an example, but that's what we're trying to achieve there. Okay, now these do take a bit of time to do. Okay, they do take a fair length of time to do. So let's have a wee go at one just now. Okay, so let's look at example. You want example 3? Yeah, 3. Okay, so we're going to find the inverse of matrix P, just 3x3, and that equals 2, 2, 1, 2, 4, 1, 3, 2, 0. Okay, so that's a 0, not a 6. So that's a 6, let's change that, it just be 0. 0. Okay, so we're going to start with the matrix there for P, and our job is to get the inverse matrix there. Okay, so we start off with the augmented matrix. We write down our P matrix, which is 2, 2, 1, 2, 4, 1, 3, 2, 0. And then on the right hand side, we're going to have the identity matrix for a 3x3, which we've seen has that form there. Okay, so that's what we're starting off with. And our job here is to create the identity matrix here. Okay, that's our job here. So what we're going to do is, again, you still try and start off with the bottom corner like you do with Gauss elimination. Okay, so the first places I'm going to try and get zeros into will be those entries there. Okay, so to do that, okay, well, row 2, that's going to be row 2 take away row 1. Row 3, okay, well, I'm going to double row 3, then take off 3 lots of row 1. Okay, so that's how I'm going to do them there. Okay, so let's see what we get when we do those steps there. But I've got to do it for this side over here as well. Those same operations that I've decided to do, I'm going to do over here as well. Okay, so what that'll give me, well, row 1, sorry, staying the same. Okay, well, if I subtract row 1 from row 2, so that's 0 there, that's now 2 there, that's a 0 there. Then I've got minus 1 there, because I've got 0 take away 1, 1, 0. Okay, so that's row 2 done there. And then I've got to times everything in row 3 by 2 and subtract 3 lots of row 1 off it, so I'm going to get 0 there. 2 lots of 2 is 4, take away 3 lots of 2, which is 6, so that's going to be minus 2. 0 times 2 is 0, take away 3 lots of 1, that's going to be minus 3 there. Okay. 0 times that by 2, well, that's nothing. Still take away 3 lots, so that's minus 3 there. 2 zeros, just leave that as a 0. 2 lots of 1 is 2. Subtract 3 lots of nothing is still just 2. Okay, so that's what my row 2 and row 3 look like now. Okay, so that's what we're trying to achieve here. Okay, my next 0 value that I want to try and obtain is going to be here. And there. Okay, because remember, I need the identity matrix to have zeros in these 2 places now. Okay, so I'm going to fix them, but I'm going to use row 2 to do it. Okay, so I'm not affecting anything else. Okay, so row 1. Okay, so how I'm going to change row 1 is I'm going to do row 1 take away row 2. Okay, and I'm going to do row 3, which will be row 3 plus row 2. Okay, that way those entries will end up becoming 0 there. Okay, so I've got to do row 1, which is row 1 take away row 2, so that's still going to be a 2 at the top there. 2 take away 2 is 0, 1 take away 0 is 1. Then row 2, so I've still got to do the right hand side, so I'm subtracting, so 1 take away negative 1 is 2, 0 take away 1 is negative 1, 0 take away 0 is 0. Okay, so that's row 1. Now change row 2 staying the same. Okay, now I'm doing row 3 plus row 2, so 0 plus 0 is 0, negative 2 plus 2 is 0, negative 3 plus 0 is still negative 3. And here, negative 3 plus minus 1 is negative 4, 0 plus 1 is 1, 2 plus 0 is 2. Okay, so I've now got that there. So you can see my left hand side is getting closer to looking at the identity matrix. The only value that I still need to get a 0 in is now this position here, isn't it? Okay, I still need to get a 0 in there. Don't worry that they're not ones just yet, the other ones, because we can take like a half of each row, yeah, and we can get ones that way. Okay, so don't worry too much. It's more just the 0's your first goal is here. So let's see how we're going to do this one. Okay, so I want to now change row 1. But I don't want to try and change it so that it's going to impact on any other positions. Like, I don't want to change a 0 into something else. So I'm just going to use row 3 to do it, okay? Because the other 2 zeros will keep that in place. So how I'm going to do that? Well, I'm going to do 3 lots of row 1 plus row 3. Okay, that way I'm going to get a 0 in that position there. So I get 2. Oh, that's not right, sorry. It's wrong straight away. I've still got times row 1 actually. Oh. Let's try that again. There we are. So 3 lots of row 1, 3 lots of 2 is 6, plus 0, that's just 6. Underneath me have to do 6. 0 plus, well, that's just zeros there, they don't change. 3 lots of 1 plus negative 3, well, that's now 0. Okay, this is where it now gets a bit trickier. So I've got the 3 lots of 2, which is 6, plus negative 4, that's now 10. Okay, negative 1 times 3 is negative 3, plus 1, negative 2. 3 lots of 0 is 0, plus 2, that's 2. Okay, so that's my first row done. The other rows now just stay the same. 0, 2, 0, negative 1, 1, 0, 0, 0, minus 3, minus 4, 1, 2. So you can now see my left hand side is very close to the identity matrix. Yeah. What I'm now going to do is I'm now going to have I done that right?
I think it should be a 2 in the top corner.
So I was about to say I think that doesn't look right to me. That should be a 2 in there. I think I've done the wrong operation there. 2. Yep, that's what it should be. Okay. So what we're now going to do is we're going to change row 1 by just taking a sixth of row 1. We're going to change row 2 by taking a half of row 2. We're going to change row 3 by taking negative a third of row 3. Okay, so do you understand why it's got to be negative a third? Because I need that to be a 1 there. Okay, not just negative 1. It's got to be a 1 there. And what that leads to... Oh, just lost all my working again. So what that leads to is I'm going to have the identity matrix here. Okay, so if I take a sixth of everything on the top row, that's going to give me a third, minus a third, and a third. If I take a half of everything in row 2, that's going to be minus a half, and 0 still. And if I take a negative a third of everything here, that's going to be 4 thirds, negative a third, and 2 thirds. Okay, so now I've got my identity matrix on the left hand side. I can now tell what my P inverse is. So P inverse, which is the right hand side.
Sorry. Shouldn't it be negative 2 thirds?
It is, you're right. It should be negative 2 thirds. Right, I forgot to change that one. Negative 2 thirds. Thank you. So P inverse is a third, minus a third, positive a third, minus a half, 0, 4 thirds, minus a third, and minus 2 thirds there. Okay. Or if you wanted to make it look a bit nicer, okay, if you actually brought out a common factor of a 6 out of everything, okay, then it would be 2 minus 2, 2, negative 3, 3, 0, and 8 minus 2, minus 4. Okay, but that's how you get the inverse of a 3 by 3 matrix, a lot more complicated. You okay with that, folks?